They obtain the condition for constructive and destructive interference. Okay, and this is a mathematical approach by which you are finding the condition for the constructive and destructive interference. Now see, there are two sources. It is very easy to understand and properly follow it. Okay, write everything in the notebook simultaneously, then you can understand it nicely. Okay, this point S1 is the first source and this is the second source of wave. Now this point Q is the point where these two waves are getting superimposed. Let us assume that the point Q is at distance 7 times lambda, that is 7 times the wavelength from the first source, and this point Q is at the distance, say S2Q is 9 times the wavelength of the second source. Wavelength of both the sources are same. Okay, so the difference S2Q minus S1Q is 2 lambda, or that is the path difference. Try to understand difference of path. Okay, that is 2 lambda. Hence the waves emerging from S1 will arrive exactly 2 cycles earlier than the waves from S2 and will again be in phase. So waves which are emerging out from S1, because they have to travel less distance, so they will reach earlier at point Q, and the waves which are coming from S2 will reach late. But how much late? Then we can say the difference is 2 times lambda, 2 times wavelength. Now one wavelength, this is the one wavelength. So we can say it is, say, one phase. Okay, so one phase and this is second phase. So we can say that the waves which are reaching from S2 are late by 2 phases, or we can say the waves from S1 are reaching 2 phases earlier than the waves from the second source. Okay, now we can say that whenever there is one wavelength, the phase is 2 pi. Now there are two phases, or we can say there is a phase difference of 2 phase. Okay, 2 phase means 2 cycles, we can say one cycle and the second cycle. So for one cycle the phase difference is 2 pi, the other will have also 2 pi, so there is a phase difference of 4 pi between the first and the second wave. Okay, first and the second wave. So we can say the first wave is having the wave equation, say for example it is y1 is equal to a cos omega t. Y1 is equal to a cos omega t. Then second wave will have the phase less by 4 pi because it is reaching late. And as you know, cos theta minus 4 pi is cos 4 pi minus theta, cos of minus theta is cos theta only. So it will become a cos omega t. So y2 will also a cos omega t. Okay. Now both the waves will be in phase together again, we can say. So phase at Q point for first wave is a cos omega t, or its wave equation is y1 is equal to a cos omega t. So its phase is omega t. Okay, what is the phase of the wave at Q from the first source? Then that first source is having, or we can say wave from the first source is having the phase omega t at point Q, and the other wave which is coming from S2 will also have the same phase, that is omega t, or we can say both are in phase again when they are reaching at point Q. Okay, here distance between S1 and S2 is, say, d, and the distance S1q and S2q are much greater then this d, we can say the distance between S1 and S2 is small d. Okay, and the distance of this S1q and S2q is very large in comparison to this small d. Okay, so we can treat, or we can say S1q and S2q are not equal. The amplitude of the displacement produced by each wave very nearly the same, or we can say the displacement which is produced at point q, that of the particle which is at point q, will have the same amplitude which is produced by both the waves. Hence, intensity due to constructive interference at point P will be 4I0, as we have discussed earlier, where I0 is the intensity of each wave. Okay, and path difference is here 2 lambda. Then if there is 3 lambda, 4 lambda, every time this will be the same condition. Okay, there will be either 2 pi, 4 pi, 5 pi, that way the phase difference would be. Okay, and the path difference will be always S2q minus S1q. In general, it can be n lambda. So for constructive interference, try to understand the difference between superimposing wave, or we can say path difference between superimposing wave must be equal to n lambda, where n is 0, 1, 2, 3. Then the intensity at point will be maximum, that is 4I0. So for constructive interference, the path difference must be n lambda. Okay. Now we take, or we can say now we know that lambda is the path difference, or we can say whenever there is a path difference lambda, there will be a phase difference of 2 pi. So whenever there is path difference of lambda, there will be a phase difference of 2 pi. This you must know. If the phase difference between superimposing wave is 2n pi, where n is 0, 1, 2, 3, then the intensity will be maximum and constructive interference will be formed, we can say, in general. Okay, now the new case, say for example, one source, that is S1 source, the other source is S2 source, another point R is taken in the medium, and the distance of this R from S1 is 9.75 lambda, and distance of the point R from second source is 7.25 lambda. Now if you take path difference, that is S2R minus S1R will be 2.5 lambda. Okay, so the difference of path is 2.5 lambda. Thus, the waves emerging from S1 will arrive exactly 2.5 cycles later. Try to understand, because the distance of R, you can see distance of R from S1, distance of R from S1 is larger than S2R. So the waves which are coming from S1 will reach at point R late by, or we can say later they will reach, because they have to travel larger distance, 9.75 lambda. So they are reaching 2.5 phase late. Try to understand, one phase is, this is 1, that is 2 pi phase difference, then this is 4 pi and half, that is 5 pi. There will be a phase difference of 5 pi radian. Okay, now if you see, if you take this, say for example the y1 is having the equation, or we can say the wave equation for the first source, y1 is equal to a cos omega t. Then for the second, that is y2 will be a cos omega t plus 5 pi, because the second wave has reached earlier. So it has started oscillating earlier, or the particle has started oscillating earlier by 2.5 phase. or we can say the phase of the first wave is 2.5 times phase ahead, and 2.5 into 2 pi will give you 5 pi. So its phase is more by 5 pi than the first wave. And therefore, if you write the equation for the displacement due to second wave at point R will be y2 is equal to a cos omega t plus 5 pi, and therefore it will become minus a cos omega t. And if you take the superposition principle, okay, then what will happen? Y1 plus y2, okay, it will give zero intensity, or this point where the phase difference is like this, that is 5 pi, 7 pi, okay, that is odd number we can say. Then what will happen? There will be a zero intensity of the point where these two waves are getting superimposed, okay, and there will be a destructive interference. Thus the path difference between the waves emerging from S1 and S2 at point R is n plus 1 by 2 lambda. It is written in general n plus 1 by 2, n plus 1 by 2 into lambda, okay, n is 0, 1, 2, 3, okay, or we can write in the phase difference, if the phase difference is 2n plus 1 pi, then there will be a destructive interference, or we can say the condition for the destructive interference can be if the path difference between the superposed wave at point is 2n plus 1 lambda, where n is 0, 1, 2, 3, then the intensity of light at that point will be 0, and this is called the destructive interference. Or in terms of phase difference, if you want to write, then if the phase difference between the superimposed wave is n plus 1 by 2 times pi, or it is 2n plus 1 into pi, okay, then what will happen? There will be a zero intensity. Here n is taken to be 0, 1, 2, 3, okay, and this is called the destructive interference. Try to watch this video 2-3 times and look into the textbook and video simultaneously, and write everything in the notebook. Very important question for the point of view of exam. Thank you very much.